Hello, welcome to MR-CFD. In this video, I want to explain how to generate the geometry and mesh of this product mountain external airflow in AssistFlow software. Let's start generating the geometry. First, open a workbench window. When the workbench window is opened like this, from the toolbox, component system, choose geometry and drag it to the blank window of workbench. Then right click on it and select Space Claim as the software to generate your geometry. Click on it. After opening the Space Claim window, we should read the base geometry of this problem, which is a mountain. To that file and open, and then find your desired geometry. Yes, here it is, the base geometry, which is a mountain. Open it. So yeah, as you see, this is a solid. If you click on the structure, this is solid. And now we are going to make a domain around it to simulate airflow. And now it's time to click on the plane in create section of this toolbar. Yeah, and click on the surface of the mountain, so the plane is created on it. Back to select, and this time choose the plane, and then by using move command, move the plane, for example, about 10 millimeters. Here the length of movement is not important, so yeah. Actually, because the dimensions of this problem are in meter, let me change the unit. So go to Space Claim options, and then from this list you can choose units, and here the length unit would be changed to meters. So okay, and now yeah, this is the meter. And now click on the plane and make a sketch on it by clicking on this one, plan view. You can look at the geometry in this view actually. And now I want to make a rectangle, actually a square, so that I can create the domain around the mountain. So click on rectangle, and from the center, 7.5 and 7.5. Actually, this is a quarter of the whole surface I want to create. Okay, so using mirror command and mirror plane this one, repeat these edges, and next time using this edge as the mirror plane, and now repeat these edges. Okay, and by using trim command, remove these edges. Okay, that's it. And now we can back to 3D mode. So yeah, we can see how the surface is created. Now the surface is separated from the solid, and here, yes, solid surface. Okay, and next time we are going to extrude this surface so that the solid of domain would be made. To do that, choose pull command and right click on the surface, activate normal, and extrude it about 5 meters. Good. So again, yeah, so now there is no surface anymore. and the surface is converted to solid. But now it's time to remove the mountain as the solid inside the dummy. Actually remove it from the whole dummy. Okay, to do that we can, let me first deactivate plane. Okay, to do that first, click on the surface and then choose pull command, and again activate no merge and push it, then choose up to command, click on the surface, the bottom surface of the mountain. Yeah. So as a final step, using combine command, choose this body, then as the cutter, choose the mountain body. This is the mountain body. Okay, and now this option is activated. To remove the solid of the mountain, you should click on it, or right click on it and delete. And again we have it here, another one, so right click and delete. So yeah, here we have only one solid that the body of the mountain is removed from, and you can only see the mountain walls. Okay, speaking of the dimension of the domain, I can say that the 5 meters height is crucial for capturing the vertical flow patterns as air moves over the mountain. It allows for the simulation of updrafts, downdrafts, and potential flow suppression at the mountain peak. And the 15 meters length provides sufficient space to model the approach flow before it hits the mountain and the wake region behind it. This is essential for studying flow suppression and vortex formation. So the geometry is generated and we can transfer it to ANSYS meshing. So close space clay. After closing a space column, you can see green check mark is activated for geometry, and then we can choose mesh from the toolbar and drag it to the workbench window. Then click on geometry and draw it to the box of B. So yeah, here we have the geometry, and now we can double click on mesh. So ANSYS meshing software will be opened. So the geometry is transferred to ANSYS meshing software. You can see it here. First of all, check mesh details, and physics preference should be on CFD. And after that, it's better first name the boundaries. So I choose the surface, right click, create new selection, and I name it as inlet. And the other side would be the outlet, and by getting Ctrl key on your keyboard, choose these two surfaces and name them as side. When you name the boundaries of the geometry, name selection is created here, inlet, outlet, and side, and the surface is named as the top. This one is named as bottom. And also we have to name all the walls of the mountain, which the number of them. And then we have to name the mountain walls, which are many walls to that. First, select all, and then by getting Control key and unselecting the other ones, you can see only the walls of the mountain are selected. Actually, this way we selected them more easily. Okay, so right click and creative selection and name them as wall mountain. Okay, now it's time to give element size to the whole geometry as the primary meshing. For example, 0.5 meters. Right click on mesh and generate mesh. The meshing is done. Actually, this is the primary meshing. Yeah, you can see how the mountain walls are meshed, and this is the whole domain. And if you want to check how many cells are created, you can expand statistics. Here is the number of elements, which is about 400,000. And we want to increase these elements. To do that, we can go for element size and reduce it. For example, I change it to 0.3 meters. Then again, back to mesh, right click on it and update. So yeah, the meshing is done, and here the meshing of the mountain wall, and it is the whole domain, and it's ready to transfer to ANSYS Fluent to start the simulation airflow around the mountain. Actually, we updated the mesh, but whenever you want to transfer meshing data to ANSYS Fluent, you should right click and then update. Then you can close it and start ANSYS Fluent. Hope this video is helpful for you. To benefit from MR-CFD services including simulation, consultation, and training, visit our website www.mrcfd.com or contact us via info@mrcfd.com.